Our next presentation will be about making Night City look great without limiting artists. And our speaker today will be Karol Kowalczyk. He is the pipeline technical artist at CD PROJEKT RED. So please welcome him. And if you're ready, you can start your presentation. Perfect. Then you can go.
It's so nice to see you, especially those familiar faces that I met today and yesterday. My name is Karol Kowalczyk, and I'm a pipeline technical artist, and I already know that you have no idea what I am doing. Even if some of you are technical artists, because I've spoke to you already, and we do different stuff. We can go into technical details, but I think it's best to show how the game would look without our work.
Don't be mean now. Remember, I'm old. I got a shaky Gannic hand. Could slip. Lights out for a minute, all right? A little discomfort at first. Blurred vision, low contrast, glitches. Well, how's it look? Feel all right to you?
Oh, this is fantastic, Vic.
Stanley here with you, and we got another day ahead of us in this city of dreams. Ooh, I love this town. Love it like you might love a mother who popped you out on the steps of an orphanage once and now stops you to ask if you got a smoke for her. Every new day here means 100 new arrivals, but only half these gonks will survive a year, and that's if it's a good one. And why do these peeps come to NC? Well, to be street samurai like Morgan, Blackhand, and Waylon Boa Boa. The greater the risk, the bigger the bounty, kids. Or so they say. But you can only be a Major League player for so long. The faster you live, the faster you burn out. If you don't get a bullet to the brain first. AC's legends. Know where you'll find most of them? The graveyard. Matters not where you're from. Matters not where you start. What matters here is the walk you walk. In Night City. The city of dreams.
What you see on the screen while you're playing the game is work of many teams. My team, the pipeline team, is responsible for making tools. There is also a couple guys making shaders, and there is also a rendering team. Together, we decided to improve what we already knew as a typical texturing system, and we created our own. And I'm already curious, how many of you are 3D graphics, maybe concept artists, designers? You can raise your hand. Don't be shy. Okay, there are probably also some maybe programmers, maybe even technical artists, and I guess maybe some CEOs, directors, people from marketing. And when creating this presentation, I thought maybe we should make it good for everyone and go step by step from what we took from games that were already created and what issues we had, why we actually wanted to introduce something new, something custom made just for one game. And if we go back to the roots, we'll find two main things that we have made by previous generations. One of them is UV mapping. It's like taking a simple mesh, anything you have in game, a garment like this t-shirt or just a cube, and cutting it and being able to wrap it with some other texture, with some image. But also, we have to think about how those textures evolved in time. At the beginning, like in games like the Doom, they were very, very, very simple. They were just a single image, and there was no real lighting in the game. You may have some shadows, but you see all those details, shiny stuff, maybe color tint, everything is in a single texture. And it was pretty popular. Even when the graphics were getting better, the resolution was changing, everything was painted onto the single texture. Then was some revolution. You can already see that the game is looking way, way better, but let's take a look on the debug frame. Here you can see a texture called diffuse, and if you have some 3D background, you know that the diffuse one is the color, but also some baked lighting and maybe more detail. But there are also other textures like normal map, which is responsible for faking the bumps on the mesh, so we can have lower poly count, or maybe some roughness or specular responsible for how rough or for specularity color of the model. Right now, we don't use names like specular or like diffuse. We have different names because it was evolving. However, that's the moment when we started using few different textures to describe a single material. Later, it was improved by some research, and we got to the point when we wanted to have everything physically correct, which we call PBR. That stands for physically based rendering. But that's still not everything that we need. We have it, we still use it. We have UV maps like here on the mesh that we used in our game, but we had to improve it a bit. And to think about those improvements, about those changes, you have to stop thinking about just the games, but you have to start thinking about the tools that were used. So we already talked about UV layout, and that's what we used at the very beginning. If you ever played with Blender or something like 5-10 years ago, or maybe even yesterday, you could have exported UV layout to GIMP, to Photoshop, Krita, or anything, and you were probably painting over it. And you already noticed that you have no preview. You are working with 2D canvas, and you have to save, export stuff, load it to, I don't know, engine, maybe to Maya, Blender, and then you see what you got. Also, as we talked before, we have few different maps, like normal map and diffuse map. So if I put a tiny screw on a model, and I want to have it looking properly, I have to edit 2 or 3 or maybe even 4 textures. And then I want to move it somewhere else, and I have to keep it aligned on all of them. That's pretty annoying. There is also no PBR. There is no concept of putting material with specific parameters. You have to tweak everything yourself. And also, you are resolution bound, which is one of the foundations of our system, which we'll talk about later. If you start creating a texture that is 2K, you cannot just make it 4K if you want to make, I don't know, maybe remaster, or the new generation of console is coming, or you just thought that there is a new GPU and you want higher res. You cannot do that. You may think about some upscaling algorithms, but they are not perfect. It's not like creating it 4K from scratch. So how could we improve it? First, we could try having 3D preview, and people were hacking their way. This video is from Photoshop, and I was looking for something that is old. Literally, I started Googling with filter that limited all the records. So the newest one could be from 2010. That's pretty old, and the guy, if you read, is using Quadro GPU, and that I guess that thing wasn't available for most of people with typical graphic cards. And then it was noticed by a few companies like Quixel, and they started making their own plugins. They wanted to bring the ability to have the preview, but they wanted it the non-hacky way. They wanted you to be able to tweak everything, to work on all the textures simultaneously, to maybe then have some library of materials like here. And what was very good in those materials is that they weren't PBR yet. However, Quixel kept developing those things. And when you think about those materials as the masks that need specific parameters, you will discover that if you keep parameters correct and correct masks, you will get physically based rendering. And that's the direction they follow. They actually right now are making great photogrammetry, and they are well known. If you use Unreal Engine, you probably know them for that. But let's move on. That's a big improvement. We have live preview. we can paint with material. You have already seen the library, and you may assume that it leads to PBR as well. And another good thing is that the painting with material means that you have this consistency. If you change something on one layer, it changes on all of them. But it's not perfect yet. We could do better. Maybe we wanted to be able to paint on 3D mesh. You can do it in Blender, you can do it in Modo, you can do it in lots of softwares. You weren't able to do it before. And the thing is, we could build upon that. We could make something that will fix also issues like the resolution. So, if you're painting right now, you have the resolution of the texture. It also has to be pretty high if you want a big detail. And you are painting all those textures like normal maps, diffuse or albedo or anything separately, but we'll fix it later. So, how do we fix it? We can try making a hacky demonstration by assigning materials to masks. We'll treat white as information that there is some material and black as the opposite. We can create node setup, which is of course tedious, but the thing is that once we have it and we are able to assign materials, they are tweakable, we can assign some tileable texture, and then the issue of resolution will not be about the material that is on the mesh, it will be issue of resolution of the mask, which is less important, and what's more, you can tweak it later, so it's non-distractible. The issue with this pipeline is that it's not perfect. It's hacky, it's made in Blender, it's in a single software. Then you move to, I don't know, Red Engine, Unreal, Unity, and you have to do the same thing from scratch. And you probably have to export those masks separately. You have to store information about the materials somewhere. And you have to make sure that if you update it in one place, it gets updated everywhere. What is more, you lost something. You no longer have a good editor for textures. You probably know how it looks in Blender if you used it. It's very junky, and you are not really painting with pre-made material. You have no library like in Quixel. So why don't we use a proper tool? And the two most popular ones are Substance and Mari. And the thing is, you may be wondering which one is better, which one we picked and why. And my answer is that they are equal. It doesn't matter which tool is best. What is important is which tool is best for your use, and we chose Substance Painter because it's popular in game dev, everyone knows how to use it, and it's pretty simple to learn. Mari, however, is very popular in VFX industry. It's capable of super ultra high resolution. The thing is, we don't need that. We cannot have ultra high-res textures because we wouldn't have performance in games. So, Substance. And if you haven't used Substance, it's a well-made suit for just what we need. You are dropping materials, you paint those masks, but everything is made in one place. It has nice preview, you can tweak the light, you can work both with enviro, with characters, you can bake normal maps from high-res resolution models to the low poly ones, and you have also a separate editor, Substance Designer, for creating those materials. So we don't have to tailor those tools ourselves, and we don't have to keep updating them to not stay less developed than the original one, which is Substance. But what is the issue? Because you know Substance, I guess, and most of people do, and it's well used. I don't know, I heard about it in 2014, I guess, maybe earlier. So what is the thing? Performance. You have to bake those textures. And they are 4K, 8K, maybe bigger, and if you want to have that detail, it has to be high res. Why? We bake those. We have 4 free textures, And you cannot have detail like those stripes here that should be normally tiled, made, baked, and look good, because it's not only the material that is tiling, there is also dirt over it. So you cannot tile the dirt. It would look repetitive. So you had those material layers at the beginning, you baked them, and they were the program was trying to fit them into maybe 4K texture, and that's how it looks after importing to Blender. Pretty terrible. So why do we have a nice solution and lose it? Why can't we have the nice things? Why do we have to work around of it? Why do we have to export it when you could use what you had already? And that's what we made. We paint those masks, we paint those layers, and we keep them. We have material library, so we can keep a base of materials, and we have them set at the beginning production. So if you want to update a material that is used commonly around the whole Night City, it will be updated in the whole game. If you want to create something custom, you can make a copy, and then the rest of it will be untouched. You put it on a new mesh, and that's how we have this consistency. And we're also no more limited by the resolution of the texture itself. We have masks, but they can be pretty low res, and I will show it on the on one of the videos on the next slides. But let's start from the beginning. You created some mesh, you are doing it in Maya, Blender, or any software you prefer. Then you have to set layers. You can do such things in Substance, but it would be probably easier if you were doing it in the software where you created the mesh. So you do it, and you can already assign some materials. If you really want to, you can enable some preview and you can start tweaking them. However, it would be probably easier if you were doing it in Substance. In Substance, you have a panel on the left side, which is made for running the tools, changing the shaders. And one of very important things there is that you have viewport parity with the game. So what you see in Substance is what you will get in the Red Engine editor and game. You don't have to wait for importing it. You have constant feedback, and artists are not getting annoyed by tweaking the tint of the color. And if you have been using Substance in the past, you may notice that if you export something to Blender or to Maya and you try to render, you get completely different results. We don't have this issue. We have shader made by our rendering team, and we have also LUTs for color display, and this issue was avoided. But how does the painting itself look like? The artist is painting with a very low resolution texture. It's simple, and it's paints with material, very similar to what you normally see. However, as you will notice just in a minute, it is more tweakable later, even in Maya. And those textures can be as small as 128 pixels in case of environmental things. They sometimes go high to 512, and in case of garments on characters, it's bigger. It's 1024 to 2048, but it's still quite small. And as those masks are painted, they only say where specific material is located. However, we also have another texture, which is called microblend, and they are being changed right now, which is kind of alpha overlay. And thanks to that texture, there is no weird issue of blending between those textures. That's why highlight, but we cannot rotate it because we wanted to keep shader as simple as possible. So if you really need some rotation, you have to work with UV map, but it's better to optimize resource than to try optimizing the shader later. And of course, you can tweak it anytime you want. So if it doesn't look good for your art director, you get back to Substance, you update a single file, and it's done. You also can see that we're tweaking material itself. It has a separate texture that is tiled, and those materials usually have 128 pixels to 512. However, sometimes we have even such small ones like 64 by 64, because if you have materials like carbon or some garment, then they can be tiled very easily and they don't need high resolution. There is also this color swatch on the over the preview, and that one is based on colors selected by a separate artist who is making sure that those colors are PBR correct, and also things like roughness, metalness, normal strength are tweaked by him. So there is no chance that you will create metal material that could have roughness that wouldn't occur in normal life. You may notice that we changed the shader, the one that is with the rebar, and when we open it in engine, we have pretty good parity. But it's not just making a single asset. We need variants. We have color coding in Night City. Like if you go to Kabuki, everything's gonna be in this bluish, greenish color. If you go to Chinatown, expect more reddish. And those assets are used all over the Night City. So we need color variants. But let's take it to another level. We can have variants for garments. Like we have a t-shirt and we want different textures on it. We need to create them rapidly. So how do we do it? We keep data in two separate files. One of them is masks. Those 10 or 20 layers that you've painted in Substance are saved into a resource called mlmask file. And we have custom compression there, so it doesn't take much space. Then the data that is being tweaked by you in Substance or in Maya or even standalone program, because we can do it standalone and save file and have preview in Red Engine. That data is called multi-layer setup file, and you can create 10 or 20 of those. In nutshell, you have 20 variants, 20 files that describe parameters, but only one file for the textures itself. If you need something custom like blood spilled over the body, over the garment, then yes, we are making a separate material mask, but why would we do it for cases like the one on the screen? So, is it perfect? I think it's quite good, but there are issues. One of them is limit of the layers. We have 20 layers limit due to performance, because it's never just one layer. If you have some garment, then you know these stripes are separate material, then you have some leather here, then you have one color of dirt, another layer of dirt. You know, it's never the same. Sometimes it's a bit reddish vibe. Maybe there is a bit of blood. So artists use up to 20 when it comes to characters, but usually it's 5 or 10 is okay for environment or even less. Another thing is that we have finite number of the materials. They are prepared by a separate artist. You can create a new one, but you cannot create one while working in Substance. You have to open a separate application called Multi-Layer Material Manager, and you have to work with that. It gives a bit less freedom to artists. However, on the other side, we have consistency, and that's quite important. We also cannot use custom images on the textures. That means that if you want to have some logo on a t-shirt or maybe patch on the arm, you have to use a separate mesh with separate texture, with separate material, because if we are trying to imitate the patch with multi-layer, we would probably have to paint each color separately, which wouldn't make sense. And another thing is that it's not suitable for photogrammetry. That sounds a bit simple, stupid, maybe silly, but you cannot simply come with camera, scan something, and get multi-layer material out of it. At least not with the technology we used for Cyberpunk. But I'm talking about limitations, and I probably forgot about the good things. We got rid of the biggest issues we had at the beginning. We no longer are resolution bound. We have the live preview actually everywhere. We don't only have live preview when adjusting the material, we have parity in all the softwares. Rendering is consistent everywhere, so it doesn't need you to keep exporting and importing stuff all the way. We have PBR, and it's very, very easy to modify assets and to create variants at any stage of the production. You can update not only the asset itself, but also the whole library of materials if you really need a change. And also, it's easy to learn. And that is very short sentence, but I think there is a lot of things that stand, that give meaning to it, because we were trying to make it as easy to learn for the artist and as easy to iterate, as fluent to work with as possible. Because if we made tools that artists didn't like, they would spend as little time on the asset and they would move on to another one once the first one is ready. But if you like it, you will keep trying, you will keep experimenting, you will try to fantasize, you will make that more vivid, more creative, and they are artists. They want to play with it. They didn't come here just to get money. They really want to get creative. And if you give them tools that are unusable and are crashing each time, they are just gonna create that asset and move on. So we really put a lot of effort, and I mean not only making it stable and not only trying to keep parity, we were trying to make all the errors as easy to understand as possible. If you don't have some resources and program should crash, it will tell you what resources to download before it crashes. If you want to change size of the thumbnails, you will change size of the thumbnails. If you want to add comments to the layers because you don't remember what is where, you can add it. You can hide layers, you have previews. If you care about performance, you can enable special preview that will show you how layers overlap with each other. And is it heavy or not? Because we don't render parts of the material that are covered completely by other layers and are not visible. It would make no sense. So we optimize it. It's not visible. So you can stack 20 layers, but if half of them isn't visible at any time, those pixels will not be showed. What else? We just let them create UI themselves. We were trying to make something as easy to use for us at the beginning, but we've let them create a screenshot, open it in Photoshop, and rearrange buttons and everything themselves. Then we started iterating on that, and we were gradually making it more UX user-friendly for them. We were introducing things like automatic scrolling when mouse is in a specific area, swapping those layers, or maybe just having a search bar or ability to mark favorite materials so you don't have to keep looking for them. And what else? It's pretty optimized. It's not the only shader used in game. It's the most common one that is used on all the environment assets, on characters, on garment, on most of the stuff. And that means that if you care for this specific shader and if you optimize it, you are optimizing the whole game. For instance, we were able to sort the way it is batching. Is any rendering programmer here? No program is cool. So we have something called draw call. Draw call is like CPU talking to GPU, and he tells, listen, I want to display something. It is this specific mesh with this shader and those parameters. And it does it a million times a second. However, if it's getting various stuff, it's like having a long course book and having to jump from page to page. It's been already long, but you're wasting most of the time verting pages. So why don't we sort it? We render multi-layer material as the first one, so there is no context switching between those. Of course, each mesh is separate, but the shader data and parameters are pretty similar, and you don't have to jump in the memory or rearrange anything. So that's how we do it. We also didn't introduce things like transparency. If you have any windows in game, there are two kinds. Ones that are transparent, maybe with distraction, maybe without it, but it's not multi-layer material. And the other kind is those which are pure gloss. If you're running through the city, you usually cannot look into the buildings. That's because they are black windows, glossy, and we didn't need anything else. Moving on. To summarize everything, we try to adjust tech to our needs, and that also means that if you don't need multi-layer, you shouldn't use it. Maybe you are doing some stylized low poly game and you should focus on something else. However, if you want to have something realistic, that should be the way. We don't want to limit artists without a valid reason. We want them to be creative and to do their best. We also don't want to waste solutions that are already made and that are good. If we have something like Substance Painter or Mari or any alternative, we want to be able to use that. We don't want to work with material painting and then bake textures and lose the resolution. We also want to keep the workflow non-destructive. You never know when you want to change something, you have to fix, or maybe you have to add another part for the whole model. If you don't have to do work from scratch, it's great. It's also great if you have visual feedback as fast as possible, because that is what makes everything tedious. It's like coding and having to restart the program each time you make an update. It's just tedious. You don't want that.
Your premium plan.
Oopsie. Yeah, but coming to the next slide, that
Your
is
premium
how
plan
the
will cover 90%
game
of the projected
looks
costs of
when
your
everything
rescue
is
and
applied.
treatment.
Pobrecita. Let's get her off that ice.
Oh, fuck!
She's flatlining!
V, need to know what's going on. Check the air hypo! Fuck, this is bad!
Catch, Chica!
I think... Holy shit, it worked!
Fuera, Chica! Get her outside! Fuera! Get her out! Terrace!
Landing. Stand clear. Initiating security protocol. Follow all instructions. Place the patient on the ground. 5 steps back. Now.
TT-133 to control. Patient NC570442 secured. Stimulants being administered. 70 milligrams dopamine, 110 norepinephrine, 800 fibrinogen.
And we're not the first ones who attempted. If you take a picture of this QR code, you will get some other sources where, for instance, creators of Doom had their own system of placing decals and additional detail. And there's quite a lot of those links in the code. So my question to you is to take a picture instead of scanning it, because most of the scanners expect a single URL and they just break or they open only the one. Yep, I still see you taking pictures, so I will wait, don't worry. Okay, I think we're ready. So I really have to admit that we are grateful for any helpful hands that come to us and that want to participate in the game creation. And one of them was sectoral program game ENN, which helped to co-fund the whole project, which was named living city creation, and we are grateful for that. And now there is a part where you ask questions, but the very, very important disclaimer is that the whole thing was created by many people. Some of them were making pipeline, which is me, the tool part. We were also making rendering. It was done mostly by rendering team, but also with TechArt help. And I was involved in testing it, however, not in the implementation. So I may be able to answer most of your questions, but if you ask me about rendering implementation details, I may have issues.
Yeah,
Okay.
thanks a lot.
I see already one question.
Yeah. I'm coming right to you.
Thank you.
First of all, thanks for amazing, just great speech. I have a question about material pipeline. Firstly, do you use some limitations for materials? I mean, do you use some albedo chart, roughness chart, or for different materials? And the second question, about do you prefer physical-based data in your materials, or some? I think our decisions. Thank you.
I'm not sure how to answer this question because we have a lot of papers which cover the topic, and we even have those that cover photogrammetry, pretty detailed. But we have a separate artist for tweaking materials. We actually have 2 of them, and they are responsible for it. And yes, the values are tweaked, so the values are PBR. However, I'm not sure what the source for the values is.
Yeah, thank you for the talk. I was wondering, how big is the tools team?
Tools team. When I joined TechArt, whole TechArt for Cyberpunk was about 14 people.
14?
Yeah, but we were growing, so we split. And we are still the same team, but we have sub-teams. My sub-team is called Pipeline, and there is about 7 or 8 of us. I'm not sure because we hired a few new faces recently, and we still work with others. So there's procedural, and they are responsible for things like Houdini, all the generations there, and also shaders. So multi-layer was also created with people from that team, and they are still helping from time to time, but they were also growing. So there is another team called texturing, which is very involved in that. And we also have another distraction team, but the distraction wasn't involved in multi-layer itself.
I'm going to steal another question. What's the, because you mentioned that you're not bound by the resolution because you're using the mask, right, to use the tilables, but technically speaking, the tilable materials are still texture bound, right?
Yes, you are correct. But the difference is that if I have those layers like dirt, and this example with tiling material on the nylon straps, it looks like there is no bounds there. They are there, of course, and they are important due to performance. But it's a hacky way to work around of it. Because here you have 3 textures actually. One of them is mask, and painting with mask itself is like spray painting, like not much detail. The material itself has another texture, which is tiled, which gives texture and detail to the graffiti you made, but the borders of it still look terrible. And here you add a micro blend, which fixes the thing. It's the illusion.
Yeah, it helps with the...
Yeah.
Okay, any more questions? Okay, I guess...
When I was covering the topic with someone before, I was also asked about performance thing. They were asking me what issues we have when driving through the night city with a car, because they were expecting a lot of loading and unloading. I'm here, and I'm next few seconds I'm 100 meters from here. I walked past a lot of new materials, a lot of new meshes, and I had to load them somehow to memory. So how do we do that? we have common base of those materials, and the multi-layer material is the most popular one. So the shader is just a shader. However, those textures are kept all the time in the memory. We have fixed amount of them, and they are kept in the memory, so you don't have to make those writing and loading cycles. So that's the kind of optimization we got. Of course, it consumes a bit of GPU memory, but it's small enough to be safe. No, all the microblends and all the material textures are always loaded. Yeah, they are quite low res. They're kind of stored like a single texture when they are in the memory.
Okay, if nobody else has any questions, I think we're done. Thanks a lot for an amazing
we'll
talk.
see each other on the party and also tomorrow. So if you have any questions, you can reach out to me.
Yeah, thanks again.
Bye.